Hello, how are you? Back again. This problem is fairly complicated. Can you picture a nice smooth table, flicking a playing card across it, very little friction. Maybe the playing card is a waxed card. Maybe the table is polished, very slick. What I want to calculate is the initial velocity that I threw that card across the table at. The card went 1 meter. It's 3 grams. It went 1 meter. It has a coefficient of kinetic friction of 0.1, and I want to know what the initial velocity was. Okay? Now, this is a diagram of the problem. It's horizontal, so Fn and Fw are equal. Ff is the friction. That's going to be negative. The motion is positive. Now you'll notice something very unique. I have no applied force there, do I? Well, the reason is because there is no applied force on the card as it's stopping on the table. There is no applied force. I threw the card, Warwick threw the card, and it's going to stop. So there is no applied force. It starts off with a certain velocity. That's what we're calculating. And it decreases as a result of the friction. So the friction is the net force. That's the force that's going to decelerate it. Remember we said if I have a net force of 0, I have no acceleration. It's constant velocity. Well, I'm going to have a net force, and the net force is going to be the friction. Is the card accelerating? Yes, it's accelerating. It's decelerating, but it's still accelerating. It's a negative acceleration. So I could say that my acceleration is that way. Now, because the acceleration and the velocity are not actually touching the card, I don't put those on the card. I put them up here. The only thing I have on the card are the forces. That's the only thing you have on the card. So, I have this equation. V final squared equals V naught squared plus 2A delta D. I know that delta D is D final minus D initial. I know that D initial is going to be 0. That's before I throw the card. It's not going to go a distance, so it's 0. So that cancels. I don't have any other distance. I just have a D final, which is given as 1, so I can really get rid of that F. And I get rid of this, and I can just simply say it's D. Okay? Easy? Now, one more piece of information that I want to tell you. What's the final velocity? Well, read back at the problem, and it will clearly say that the final velocity is 0. So I can put that down. Final velocity equals 0. Easy? Now, let's do the problem. I have 3 dots up here. And I'm going to write some equations. Now I know that F net, let's use a different color. I know that F net equals the friction, which is negative. Correct? How do I know it's negative? Because it's negative. It's the opposite way of the direction. So it's negative. Now, I know that the friction is going to equal mu Fn. Correct? Mu Fn. Now, that's negative. Now, mu Fn equals, let's erase some of this. You have this down? Easy, I can erase that now. All right? That's about, could be more than a third of your grade on this problem if you were taking an advanced placement test. So we'll get rid of that. Give me more room to work here. And I know that F equals negative mu Fn, which equals the net force, which equals ma. Correct? Now, I know that Fn equals Fw. Tricky? That good? Fn and Fw are the same. Therefore, I can rewrite Fn as mg. Okay? So I can say that this is going to be negative mu mg. Mg's here. Negative mu equals the F net, which is ma. Easy? Okay. I'll get rid of this. I'll get rid of this. And I'll say A equals, now you know from basic algebra, these m's are going to cancel. So I'm left with negative mu g. Negative mu g. And that makes sense because acceleration is negative. Perfect. How do I know it's negative? Remember the free body diagram? Acceleration was going contrary to the motion because it was decelerating. So that acceleration was negative. I'm going to draw that again at the end of the problem, and you'll see. So far, so good? So let's write that as our first equation up here. Negative, we'll say A. We'll say A equals negative mu g. Good? Negative mu g. Now, let's erase this. Let's erase this. Good stuff so far? Follow me? We know that V final squared equals V naught squared plus 2AD. Easy? We know that this, remember my friend Dr. Herzog? This is 0. That's 0. So I'm going to solve for this. So this is going to be, follow this? Can you follow this? This is going to be negative V naught squared equals 2AD. Correct? Now, I want to very quickly divide both sides by -1, and that becomes V naught squared equals negative 2AD. So far, so good? Okay? Let me write this. Let me get rid of this. Get rid of that. Let me get rid of this, and I'll rewrite that. So, V squared equals negative 2AD. Easy? Take the square root of both sides, and I get V, this is naught, V naught, the initial, equals square root of 2 negative 2AD. Good? That's my next equation. So V naught equals square root negative 2AD. So far, so good? Now, let's erase this. Let's erase this now. I want to substitute in for A. Let's go like this. That's A, right? And this is A. I want to substitute in for A negative mu G. So, this is what I would say. I would say V naught equals negative 2, and then A is going to be negative mu G times D. It might interest you to know that we are not taking the square root of a negative because we have negative times negative. This is not going to be a problem with imaginary numbers. Good? So now I can get rid of those. Negative times a negative is a positive. So let me rewrite the third equation. And it's going to be V naught equals square root of 2 mu G D. That's it. I think it's very cool. Notice we didn't use the mass. I really like that. I really like that. Let math be your friend, okay? Instead of running away from it like a lunatic, always afraid of math, let's embrace it. Okay. V naught equals 2 times 0.1 times G. We'll use 10 meters per second squared for G. And then D is 1. So far, so good? So this will be 2 times 0.1 is 0.2 times 10 is 2 times 1 is 2. So it'll be V naught equals, you see that? 2 times 0.1 is 0.2 times 10 is 2 times 1 is 2. So it reduces to that. All right? Now, what I want you to do is I want you to calculate that quickly. Calculate that quickly. What do you get? You get it? Root 2. You should know all of your root prime numbers. Let's say up to 31. Very helpful. Root prime numbers. That's going to be 1.4 meters per second. So that's the answer. 1.4 meters per second. Easy? So I'm going to say V naught equals 1.4 meters per second. Easy? Now, here I have my surface. Here I have the playing card. Here I have my weight. Here I have my normal. Here I have the motion. That's the motion. That's positive. Now, here I have my velocity. My initial velocity. Here I have my acceleration, negative. Correct? Here I have my friction. Negative. So I have several vectors here. I have my friction. I have my normal force, my weight, my acceleration, my initial velocity, and my motion in that way, that direction. Easy? There you have it. 1.4 meters per second. Which is pretty fast. It's pretty fast. That's 3 or 4 miles an hour. Maybe. 3. Easy? Good? All right. Thank you very much. Have a good day. And I'll leave that on the board for a few seconds. And be careful out there. Remember, always be careful. And have a great day. Bye.